So first of all, hi everyone, and thanks for joining us for another community meetup. For this meetup, we have Oleg with us. So Oleg is a developer relation engineer at Atomic Jar. And for a lot of folks who might be familiar with test containers, you might know that Atomic Jar is the company that's behind it, and they're also developing the test containers cloud that allows the organizations to basically write more resilient software and enable them with some really fast integration tests and more. So test container has been used by a lot of various big tech companies across the industry. And over the past few months where we have been talking with a lot of customers, we realized that some of them are actually using test containers with local stack to improve their integration testing and making sure that whatever they're developing, it is working consistently in the production as well. And it's quite a pleasure to have Oleg with us because he will be walking us through about what it takes to actually adopt test containers for local development and testing, and just helping us understand like how local stack actually plays around with it quite a lot. So hi, Oleg. First of all, thanks for accepting our invite and really excited to have you here.
Hi, Harsh. I'm very excited to be here.
Awesome. Cool. So the stage is all yours. So yeah.
Right. Excellent. So today we wanted to talk about test containers and local stack. And just to, I looked at the agenda, and we wanted to have a very brief intro what test containers is and how to set it up, and then how it plays with local stack. So I thought that I will start with that. Can I share a couple of slides, or do you want me to, like, can I share my screen?
It is all up to you. So you can share slides.
Okay, cool.
So yeah.
Cool. So you should be able to see my screen, and let's just go through a couple of slides here. So you see the main slide, right? Not the presenter's notes.
Yes, we are seeing the main slide.
Very good. So my name is Oleg Shalev, and I do work at Atomic Jar, which is a startup. We are around 20 people big, and I am responsible for developer relations, which gives me an excellent opportunity to talk to developers, so to speak, in the wild who use test containers, and also have a little bit of insight into technologies that are often used with test containers, such as local stack. So if you have any questions, send me a note, send me a tweet, find me on any Slacks, and I'd be happy to chat to you about anything. Why test containers is a very exciting technology is because almost everything in software engineering, the answer to all questions is actually having tests, right? Can you merge a pull request? Do you have tests? Do they pass? Yes. Can you release something in production? Do you have tests? Are the tests passing? Are the answers? Is a new version of a dependency resolving a security vulnerability? Well, do you have tests? Do tests pass if you upgrade the dependency? The answer almost universally is this. When you're developing features, how can you be sure that you are not stepping on other people's toes, right? You're not messing something that your team is doing, like somebody else on your team is doing. Well, you run your tests and you run their tests, and they run your tests, and CI runs everyone's tests, and that's how you know, right? That's the only kind of sort of sensible way to make progress, is to have functionality covered by tests, and then go with it, right? Run the tests. And in the past, we had sort of a distinction between how we do tests, and there were a little bit maybe like philosophical distinction between what kind of tests we want to run and how we want to organize them. And I'm pretty sure you had something of like this. You've seen that before, the testing pyramid, where we would have a ton of unit tests. They will be small, they will be fast, they will be working with components in isolation. They will mock everything that is mockable, and then you'll have a bunch of them uncover over almost everything, achieve the requested code coverage goals, and be done with that. And then on top of them, you'll have integration tests, which would be maybe more complex or involve a more complex setup, and but they would run with the actual technologies that you want to run in production with. And then some like production-like environment end-to-end tests where you would deploy stuff to the staging environment and then run either automated scripts on top of that or somewhere. So, and this setup works brilliantly for a number of projects. Unfortunately, as of lately, it's not that great. Specifically when we're talking about applications that consume cloud technologies like run on AWS or any other cloud or consume other managed services, then it makes very little sense to cover everything with unit tests and mock everything, because the sources of errors are very often between, like, getting your code on the border between different components integrations. So it just makes sense that integration tests are getting much more important role in our development process. And there are a number of teams who came out with their ideas of how they rethink the testing pyramid, but most of them just converge to the same idea that there should be less, or maybe we should rely less on the implementation detail tests and rely more on the higher level functional tests that kind of go through the and use actual components in that applications will work with. So for traditional applications, that would be like you would have a real instance of your database running somewhere, or for cloud applications, you will have, well, say, for example, local stack instance running somewhere, and then because it is compatible with the actual AWS implementation, you would know that if it works in the integration test, chances are the current build is very good for working in production. And then because of that, because you have those test suites, which you can actually trust to determine the quality of your application, of your software, you can build all the DevOps practices, because before you release something, you have to test it. And you have to, this inner loop, the circle on the left is what happens in the local environment most of the time. And then test sort of kind of passes through the continuous integration pipelines. And then the right circle happens somewhere, well, in the cloud or wherever you deploy things. That happens after the release, right? But the test is the last thing that you do locally, and the first thing that you do somewhere else to ensure the compatibility between your local environments and your actual deployment targets. So, and then everything else on the left kind of follows the basic idea that to succeed with that cycle, you need to have decent tests, and then you have your environments that support those things. So how do you test locally cloud applications? Obviously, for the AWS, you would use localstack. And localstack is, I'm sure this is not maybe the correct phrasing, but this is the implementation of AWS API and services that runs in a single container that can run on your local development machine, or it can run nicely in your CI. And you can test your implementation against that, and then you can be sure that your application will work the same way in the cloud, which is great. And we would like to use that, and we would like to make the tests as simple as possible for our application. And that's where Testcontainers comes in. Testcontainers is a collection of libraries in different languages. And I come from Java background, so I'm going to show Java version on this stream, and we're going to see how it works. But the similar concepts I implemented in different languages. What it does, on one end, it integrates with Docker as a runtime to ensure the processes isolation and the configuration of software that we want our application to depend on. So in the local stack example, we're going to run local stack in the Docker container. And it gives you the flexible API to configure everything that runs within the container and how that interacts with your application. We're going to use Docker because it's available on all operating platforms. It's, well, user-friendly and everything. Developers know how to use it. Allegedly, it's one of the most loved development tools. I've seen a survey where Docker was one of the most loved development tools, which might be true. It certainly gives you a nice way to give other people a way to run your software, and on the other hand, to give other people a way for you to run their software, which is exactly what we want to do for the integration tests. Because in the same way where we can pull that image with the like stock service, right, the database, Kafka or local stack, the API is pretty universal there. So on test containers, builds on top of Docker and integrates with the runtime and provides you with the convenient API for the container lifecycle and cleanup in your programming language of choice. So you don't have to leave the IDE. It provides you with the way to configure the container and the service running within it. So both to expose and configure how Docker container interacts with your host, if you want to copy files there back and forth, or expose some ports, and the service. So if you have, I don't know, local stack in the container running, it allows you to configure that nicely with the particular service in mind. So it can configure local stack for you. And then on the other end, it provides integration with your programming languages or frameworks for application development or testing. So in the Java world, that would be Spring, that would be Micronaut, that would be Quarkus. In Python, you would have sort of maybe a Django app that kind of you can use to simplify the integration between Django and test containers Python, and so on. And all in all, we are very happy with how test container is shaping up, and the community is very happy. And recently we were put on the technology radar into the adopt category as the sort of default option for ThoughtWorks, right? But they are sort of the thought leadership in some sense in the ecosystem as the default option to create environment for tests, because test containers provides you with programmable, lightweight, disposable containers, and in general makes tests more reliable, which is exactly what we want. In this session, we're going to look at Testcontainers Java. It's a fairly old project. It's a very mature project. Docker itself is like 8 years old. So 7 years is quite a bit of years. And Testcontainers Java integrates with Docker Java API. Through Docker Java API, it talks to the Docker daemon. So it doesn't run actually commands on the command line like Docker pull or anything like that. And integrates, as I said, with frameworks in the Java ecosystem. What it does, besides just providing you an API, it does a bunch of things to ensure reliability of your environment. It does a bunch of system checks to make sure that it can actually execute things in the Docker environment the way it needs to, that you can mount files, that you can expose ports, that you can clean up the containers, which is very important because you want your tests to be repeatable. So you want to create those throwaway ephemeral containers, run the testing on that, and then clean them up. So the state there is not interfering between the test runs or even between the invocation of individual test classes or test methods. So Testcontainers provides you with the cleanup facilities. And then it tries to embody and kind of strongly encourage the better integration test practices by giving you the convenient API to do the right thing and sort of trying to hide the inconvenient API that does the wrong thing. So that goes with parallelization. We want the tests to be as fast as possible. Sometimes that means that we want to parallelize our integration tests. We want port randomization because if we would like to run, say, 2 instances of Kafka, and Kafka needs to bind on certain ports within Docker, if we expose the same ports to the same values on the host machine, there will be conflicts, nothing will work, everyone will be sad. And then, so we try to automatically do the right thing. And then the next best thing after test containers, kind of sort of the core libraries, is that there is a big community or the big ecosystem of modules that are prepared for test containers, and then they specifically work for particular technologies. And those modules provide, those modules provide you with the convenient API to create the containers with those particular technologies. You can see there is local stack there in the bottom right corner on top of Kubernetes. And then technologies there are through all kinds of like types of application. There is like Elasticsearch for the full text search engine, and there is the graph databases, and there are like normal relational databases, and there is MongoDB, there is Kafka as a message broker, or HiveMQ as a message broker, I think. And you can run Selenium. Anything that you can run in a container runs with test containers, and it's much easier to integrate and make tests against a certain technology using test containers that manage it outside of the test containers. So that's why the community is thriving and the ecosystem is growing all the time. And so, as I said, the implementations are in different languages. So if you don't like Java, you can look at the API, you can look at the basic concepts that I'm going to show in a minute, and then there are libraries that are idiomatic in the particular languages. So, for example, there is Testcontainers Node that is fully async first, that is written in idiomatic JavaScript API. You can use that in your Node.js projects, like either with Typescript or JavaScript. Or you can use Testcontainers Go, and you have the Go API, and it works as you would assume a Go application or a test library for Go applications will work. And the same is with Python and so on. So in Python, for example, you open containers with the with keyword, and then they kind of nicely fit in the language patterns. So they're good. If you want to share this presentation with your colleagues who like sort of use different languages, then you don't have to be like, oh, there is this like a Java thing. It's pretty universally across different languages. We even have the Testcontainers Rust implementation, which is very interesting to me. Right. Right. Let's look at the code. Let's look at the code. This was a quick intro. Let me just show my ID, and I'm going to show the Java application, and I'm going to show you a couple of tests. And I want you to introduce some concepts to what test containers are, how to get started with that, and then quickly go to the local stack examples there. So how do you enable test containers? Well, you go to the test containers, to your dependency management mechanism, and you import the libraries the normal way you do for your application, right? So in Java, I'm going to show the POM XML and the Maven project. You can just import the same dependencies using Gradle, or however you can npm install Testcontainers Node, and so on, right? And you can see we have a bunch of those test containers artifacts that we can use here. So, for example, we can have the databases, and we can have the Kubernetes, or we can have the Elasticsearch, and so on. And we can have the integration with JUnit, which is the test framework in Java, sort of a de facto way to run tests. And there is a neat library that integrates the extension to JUnit, which will tie the container lifecycle to the JUnit test lifecycle, which is neat, right? And then here's the application here. It's a Spring application, but what I wanted to show you here, I wanted to show you the basic API usage. The basic API usage, which is, for example, the main concept here is a generic container. Generic container, and you can have something my database, right? And we're gonna get to something. Well, let's say Redis. Redis is the simplest, right? And then you can have the new generic container, and you need to provide it with a Docker image name. So if I want to run Redis, that will be something like that, right? Redis, and there's the 6 Alpine. So generic container is abstraction that it represents the container, and in different languages will be similar ones. What's great about that I can configure everything that Docker allows me to configure using my IDE, right? So I can expose the ports, I can copy files to the container, specify networks, specify the startup strategy, like what does it mean for the container to actually start? Because I don't want just the container to start, but also the service within the container to be in the state where I can run tests against that. So the database is ready to accept queries, local stack has started, and I'm ready to do like local AWS local commands. And yeah, I can do everything that the Docker allows me. I can specify environment variables. I can specify even the pool policies and override the commands for the particular images. So usually you would just expose some sorts of ports like that, right? And then that's it. Now what I can do after that, and let's just have I have the lifecycle control methods. So I can start my Redis and I can stop my Redis if I want. And what it will do when I call Redis start, it will create the container. It will go to Docker and say, Docker daemon, please pull me the image Redis 6, and then create the container by that, apply the configuration that you specify in your tests, and then run the container. And then after I started the container, I can do cool things. For example, I can get the host or the port, or I can build any abstraction on top of that will do the right thing for me. So if I have, if I have not Redis here, but like say new Kafka module, show you, right? And it doesn't matter. I can say get Bootstrap servers, which is the helper method that will return me the configuration for that particular thing. So those modules, the ecosystem, is a great thing, because as an application developer, you don't need to know the gritty details of how to run particular technology in Docker. You just create and it needs the thing here. It needs the Docker image name, right? Some sort of Kafka Docker image we can put in there, right? And then that would be my Kafka, and I can start it and I can get the configuration from that. And that configuration, it's available at runtime, so I can feed back into my application and say, here's your Redis, here's your Kafka, here's your local stack, use it for the tests. And my application will dynamically go configure itself and go and run tests against the particular instance of local stack, which is, I think, is quite spectacular, right? So let's look at that. Shall we look at that? So here's the simplest example of an application that uses local stack container and test containers. So what we have here is it's a Spring Boot application as well. We don't even need, it doesn't do anything. There is no actual logic in the application. I wanted just to show you what it feels to work with tests using test containers and local stack now. So I have imported the local stack dependency with the test scope. So it will only be sort of available in my test class path. So test containers or those particular APIs will not contaminate your application class path if you don't want to do that. And I have my test containers JUnit integration. So let's look what I can do now. What I can do now is a pretty cool thing. I can have my test, and this is the normal configuration. I need some properties to specify that my Spring application talks to the AWS cloud for them to be. But here's the interesting thing. Here's the integration with local stack. I can just create a field or an instance of a local stack container, which is comes from the library that we just imported, right? And it comes with a pretty interesting code that configures my local stack container, expose the ports for the particular services that I want to have. I can say which services I want to use, and then gives me the getters and setters to access the particular configuration, like the regions and whatnot, right? And you can do all kinds of services that by default are enabled there, right? So you can do here we will use S3 in this example, but there is obviously the rest of them are as well, and you can even I think you can specify the string-based configuration there. So if the local stack container and local stack Docker image evolves, you can specify that. So what we say here, we want to have our local stack container from I think this is a fairly recent local stack Docker image. Right? Is it? Yeah, it's fairly recent, right? I think it's currently the latest actually, which is a pro tip. You never want to use latest, like a dynamic tag in your tests, because, well, you never know what actual like version of local stack you are testing against. So your tests can become flaky and unpredictable because of that. You want to maybe to use that if you're testing the test containers integration with local stack or something, but not in your application. So we say that we want to have the local stack 100, and we enable the S3 service. And then our test, so this is one thing, the configuration, right? The other thing is the lifecycle. The lifecycle configuration. What we do here, we use the integration with JUnit tests. We marked our class with the test containers annotation, and we mark our field with the container annotation. It will tie the lifecycle of this container, of the containers that are represented by this field, to the lifecycle of the test. So the static fields will be like one per class container, and then the instance field will be like one per test, which is interestingly enough. And then it will start before my test will run. What I can do then, when the test is running, I can say that my local stack S3 endpoint, my AWS S3 endpoint for my Spring application, I can tell you that instead of going to the default or taking one from the actual like production configuration, I want to use the S3 endpoint that my local stack object exposes. And I get that by just saying, like, get me the endpoint for S3. Or if I would have another service, then for another service. And I need to specify the region here. So this will allow my Spring application to, at runtime, to talk to my local stack container. And then before all my tests run, I can run commands in the container. So for example, I will create the buckets. I will create the bucket that I want to have, which is then my tests will use. And the tests are very sort of simple. This is just, the tests themselves are not test container specific, right? We configured our application to use our dynamically generated ephemeral local stack container, and then we can do whatever with that combination. So I will just, in this example, I will just use my normal S3 template from Spring, from Spring Cloud implementation, and I will just say, like, store something in my bucket, and then create another bucket, right? Or store something else, and then I will assert things. So, but this is like the interesting parts are all happening here in the configuration, sort of. I can run this test, of course. I can run this test, and it will run exactly the same. So this test should be passing. So let me see. What it does, let me look at the logs. What I'm trying to show you, that it talks to the, the test passes, right? The test passes, it's like very, very quick. We just start the S3 service. The startup overhead is minimal. What I'm trying to show you is the container creation, right? So test containers connects to Docker, and any compatible Docker will work. And then it runs the checks. It does everything. And then here it starts creating the containers. And it shows you with this little whale icon that stuff is happening in Docker. So local stack container is being created. The image for the local stack creator is being created. If you don't have the image in the local Docker cache, the image will be pulled from, well, Docker Hub normally, or through like whatever your normal Docker registry in use are. If you logged into something, you can configure, of course, everything there, both on the individual test level or the application level. So, and then it pulls the image, and then it starts the image. Let me find started. Right, so Rook started, and local stack started in 5 seconds, which is very quick, right? And I run this, and then I run my tests of my Spring application. But because it's a sample application, you just like it doesn't matter what my test does. I mean, I can just show you that if I change it and I run it, right, then it fails. Now it should fail because I changed some expectation there, and then you can see that the test fails, and it runs the same way. And the cool thing is, so this is the S3 example. Let me show you. If I now it failed because it's supposed to be 1, but it was 2, right? And I mean the same thing here, right? And I can run my tests from the command line, and it will run exactly the same. So that means that my CI or my colleagues will run my tests the same way. They don't need to know that the tests are using local stack. They don't need to start local stack before, right? They just need to run their normal build commands, and the tests will run with the true compatibility to the technologies that we want to run with. Local stack or Kafka or databases or anything. Isn't it spectacular, right? I fix the test and I run the test again, and then it runs spectacularly fast. There are more to the things, like, so I can have the container lifecycle. There are additional things that I can do. Specify sorry, I'm rambling. I can make the container stay after I run the tests. I can use the same API. There is nothing test specific about that API, so I can pull it into my application and say, in my application, I can say like, oh, if there is no AWS credentials specifier or URLs, create me a local stack container and work with that local stack container as the backend currently. So I would be able to run my application, not even in tests, but just run it normally as I would do during my inner loop development process. And this is another application. I just wanted to show you a little bit more complex example of, it's not complex, but like a little bit more involved example of the tests. So where we can have, this is actually from a Rigsfield blog example on testing AWS, testing Spring applications with AWS. And what the application is doing, it uses S3 as and stores things in there, and it also uses the message listener. And there is the configuration that the application, using those two are connected, right? So in my tests, I do exactly the same thing, right? I create my container. I say that I need S3, I need SQS. I can enable events if I need events, right? And I run my tests. The test looks and feels like a normal unit test. Like any Java developer knows how to run and write unit tests, and you just need to use a little bit of a library use to create a proper local stack running in a Docker container, right? So we do that, and then here in the before all, we create the queue in SQS, and we create the bucket in S3 before all the tests. Our container will be started, the queues and the bucket will be created. Then we will tell our Spring application where to find the things. So we can say like SQS is there, and this is that property that configures that for Spring, and my S3 is there, and this is that. And we can have the credentials, and we specify the queue and bucket names, which are test specific, right? So if you wanted, you could reuse that local stack instance for multiple tests and say, for example, create different buckets or create different queues. So then you don't need the isolation that starts and stops a container all the time. So you can have less isolation if you wanted. You would need to then not use the integration with JUnit, but you would manage the lifecycle yourself. But you can create like a super class or anything, and then just say local stack somewhere. Like you can say local stack start and be done with that. you don't even need to stop it, because after the tests are finalized and run, even if they crash, test containers will clean it up. That's why I've seen people actually starting test containers based containers from their build tools, like adding some groovy script into the Maven POM XML to execute a couple of lines of code and say, like, give me a local stack container or give me a database, which is an interesting engineering solution, and I would not personally recommend for that, but you can run it, right? And then our tests are exactly the same as we would expect. We can send the
Oleg, it seems, can you hear us? It seems like we've lost your audio. We can still see your screen, but cannot hear you any longer. Not sure if there was a... Okay, so Silvio just mentioned he can hear you after rejoining, so maybe we also need to rejoin then, I guess. Or... Okay.
Can you hear me now? Very good. Sorry. I thought that maybe if I would rejoin, it will simplify everything for everyone. Right. So just a few minutes more. Right. So the actual test is not important, but I just want to have a test that runs and shows you how you can use local stack for with a bunch of services enabled with the same ease. Right. It pulls the containers, it runs the containers, it starts the containers, and then you can see, can you see here? I think here you should be able to see. This is my Docker stats, and this is my Docker stats, and the container is now down. We only see Rook, which is the kind of sort of the cleanup watchdog that will also clean the containers and then stop working by itself, right? But our tests are passing, everything is good. It's just you can run it from your ID. This is the best thing, right? You don't need external configuration. You don't need YAML. You don't need anything. You can just use your local stack from your ID, as any Java developer would know how to do from their Java application. And this is the cool bit here, is that there is API which are technology specific, right? So we can have I can get the information from my local stack instance to configure things, and then I can and that helps me tremendously, right? Or I can enable services in a smart way that will save my time on the startup, and that's sort of it. Testcontainers provides so the test failed as we expected because there was no object in the bucket by that name. So it took 5 seconds because it didn't find the object, and then it waited for 5 seconds, and then it failed, right? Which is what we expected. Let me fix it back. Right. So that's sort of a small demo how you can run with test containers and local stack. You can do that in other languages. So here's a very short example in Go, for example, from the test containers Go test containers Go project, right? So runs. This doesn't necessarily need to run local stack. This is I think the waiting strategy test but it creates the container for local stack, and then it specifies the waiting strategy that the container is considered to be running when we can run this command normally, right? So this is if you speak Go, this is a little bit like this gives you a taste of the API in Go. So you create the container request, and then you create the generic container, and then you get it, right? And then you can configure your Go application to use that local stack, and all of that programmatically. So yeah, I think well, yeah, that's it. I think that's mostly it. We at Atomic Jar, what we are doing is we are building Testcontainers Cloud. As I said, Testcontainers tests will work with any compatible Docker runtime environment, right? So it doesn't have to be local. And what makes sense in a lot of cases is to defer the execution of those containers, running the containers to the cloud. So I don't have my Docker running locally, right? But I have my Testcontainers Cloud, and it connected to some sort of the serverless EVM that was provisioned for me in a serverless fashion, and I can run my tests. And so the local stack containers were running somewhere there in the VM there, and I could use that locally in my integration tests. So yeah, that is in private beta, so you cannot yet access that. But if you go to testcontainers.cloud, I think you can sign up for the private beta if you want. Right. Yeah, I think this is all sort of that I wanted to cover. Do you have questions? Do we want to talk about anything else specific to test containers, or specific test containers in local cloud, local stack? Sorry. And I see Manuel has joined. Manuel there, you can see Manuel. He's one of the maintainers of Testcontainers Go. Shout out to Manuel. Recently there was a release. So if you use Go professionally, or if you just like Go, you can go and check it out. It's a cool library.
One of the things that I was interested in is what's the vision for Testcontainers Cloud? Because we just realized that Testcontainer is a library for doing our local development and testing, but what will the cloud product actually envision? So any insights on that?
Well, the Testcontainers Cloud provides you with the runtime for your Docker containers. So you don't need to run your Docker locally, which in some companies is considered a security risk, because, well, if you run like random containers locally, there could be implications. You don't need to share the resources of your machine with the containers that run in Docker, right? So if my tests need to run, I don't know, like 3 instances of Oracle database and a local stack, right? Then my machine would not be very happy running all that by itself. Right, but in the cloud, I can have infinite resources. That's what the cloud is, right? It's like infinite resources for a little money. And on top of that, there is a lot of opportunity to parallelize things, because when you run your tests, normally your application takes a little bit of the load, and the containers in that ephemeral infrastructure takes a little bit more of the load, right? So I can parallelize my tests. I can horizontally scale my workload in the cloud, and then the test will still run locally, right? And I will get the results locally, but I will get them just faster because there are like several threads without actually having limited resources. And it works the same way in CI, and there are a number of advantages, but superior user experience, speed of execution, and the feedback cycle, and sort of stuff like that. Security are the sort of the keywords.
That sounds great. Thanks for sharing.
I have a question. Do I just go ahead, or yeah? Okay.
Yeah, go ahead, Nathan.
Thanks, Oleg. I have a question. how does this compare to CDK, for example? So if I have a setup at work and it's done, I mean, we set up our cloud infrastructure with CDK, so can we tie it to the test container services, or how would that work? Yeah, thanks.
You set up your cloud infrastructure with CDK, and you want to use that.
So use the same CDK files?
Yeah.
Because I see
you
I'm pretty
can-
much doing the same thing, because if I use test containers, I have to say, okay, give me an S3 bucket, set up, give me an S3 service, set up, open it and create a bucket and all of that. So I already do this with CDK, but then I'm doing it directly against AWS. So if I want to do it against local stack, how do I go about this? Or is it possible? Yeah.
I'm sure that is possible. I don't have a good example right now, but well, your local stack will run locally in your Docker container, and you just need to execute your CDK scripts against that instance, right? So you can definitely do that, right? So then you don't need to replicate all that setup programmatically if you have that, and then you'll have the parity between your production environment and your testing environment, which is exactly what you want.
So we actually have a question right now. Does test container for Java support both community and pro versions of local stack? So I presume that it might be yes, because we just need the API keys right there. Any insights on that?
Right. So test containers for Java, or all test containers, support anything that runs in a Docker, right? So if you can run your the pro version of local stack in a Docker and specify the configuration, then yes. Specifically the local stack module, I'm not 100% sure. I know that for other software that requires licenses, there are sometimes the convenience API that sort of says, accept the license for that, and then it will put like a file that contains, like, I know that I'm running this for the tests only. This is not production. I have the rights. I've read the license and I accept the license in the correct place, and then the container starts. If you need, so you can do that. Right, I'm not sure if local stack the local stack module supports that out of the box, but if not, you can extend it either yourself or, I don't know, submit a pull request, so everyone could do that, and that is definitely something doable. And of course, if you can always use the generic container API and just like sort of manually configure that for any Docker image that you have, either in private registries, or it doesn't even have to be in Docker Hub, but you can have your like a custom version of a given Docker image in your private registry that you're not sharing with, like, say, the internet publicly, and then you do that with whatever. And Edu suggested in the chat that if you do, like, with environment local stack API key and put the API key, it would work. So very good.
So do we have any more questions?
Right. There was a comment by Christopher that the examples were not Spring Boot and JUnit 5. That is not true. Those were Spring and JUnit 5 exactly. So the annotations-based lifecycle, like with add test containers and add container, that is implemented using JUnit 5 extension. So they were running as JUnit 5 tests. Bran is there with hard-hitting questions. Hi, Bran. The question is, what would be the recommended approach for using test containers for data migration of 20 to 25 terabytes of Oracle Exadata to AWS, either RDS or Redshift? Which, that is an interesting question. I would assume that you would want to write the integration test that both kind of. I'm not sure if Oracle Exadata actually is the Docker compatible technology that you'd run in Docker. But if it is, then write a test that spins up both and migrates a chunk of data, and then verify your migration scripts on larger chunks of data that are sort of production similar. And then when all your tests pass and you are certain that you haven't made any mistakes, you can just run the same application for the data migration. How exactly how to do that in the production, that is a separate question with a separate expertise. Which I don't have, unfortunately.
Cool. So I guess we have just 5 minutes left. So I can take up the stage to share a few quick updates about local stack in itself. So I will just sharing my screen over here. So if you might be following up with the demonstration that was put forward by Oleg, we have currently released the v1.1 release with local stack. And this has actually came up with a lot of new services and some new enhancements overall. The very first one is that we have actually started supporting the Lambda function URLs. This was one of the most requested feature on our community Slack. And we are quite grateful to have shipped this feature. So you can actually get started with function URL generation with your Lambda services, and you can play around with it. I'm recently writing a blog on this part, but you might be able to find some of the examples upon Local Stack Pro samples. Apart from this, we have also added feature for Lambda event filtering, API gate integration to execute those step functions, S3 notification to event bridge, and some more of the services, including AWS Transcribe. So this is pretty much all of the features that are mentioned here are community features, so you might be able to use them without having any sort of a pro license. For people who are using the pro licenses right now, we have rolled out the initial version for the AWS fault injection simulator service. So this might lead to folks trying out chaos engineering, testing, and all of that upon local stack itself. And we have also put forward the initial support for Neo4j graph databases in Neptune. So if you have any feedbacks regarding some of these features or things are not working out for you, we highly recommend you to start getting started with our discussion pages. So this is our Discourse forum, and this is what we are trying to use for keeping all our communication and all our content up on the same platform itself. So I'll just share the link over here so that folks can create an account, and we would greatly appreciate if you can just get started with all of your discussions here. Otherwise, if you have a technical bug, just reach out to us upon the GitHub repository itself, and we can just take that upon priority. Apart from this, we have also roll out a few blocks. And one of the premier blocks that we have rolled out is about the cloud bots. So people who are actually using our local stack pro feature, they might be already familiar, or they might have seen the cloud bots as a feature over there. So with our team tier, cloud bots basically provide a persistent state snapshot. And this allows you to basically have state management and team collaboration features within local stack itself. So we have an extensive blog over here that was written by Waldemar and Joe. And this can actually explain about what local stack was previously as an ephemeral dev environment. And right now it provides persistent state so that you can share this across your teams, and you can get started with collaborating over your local stack instances itself. So right now we are offering free team tier previews, which people can use to understand how local stack cloud bots work and to basically get an understanding for this. And you can just enroll into this through your local stack pro license itself. So I'll just share all of these links over here so that folks can get to know more about CloudBots. And if you have any sort of a feedback regarding CloudBots or any of the features around local stack itself, there is a survey and a feedback form that is linked to that message. So you can just fill that out. And lastly, we have also rolled out a new dev feature, which we call as local stack extension. And that allows the developers to basically extend and customize local stack. So you can actually start writing your own extensions within local stack, and you can run this with your local stack upstart itself. And this can be used for a variety of use cases. So some of these use cases might include trying to emulate Stripe locally within local stack itself, or maybe to instrument upon your AWS request before they reach your Lambdas, or something of that sort as well. One of our co-founders, Thomas, is actually organizing a meetup with Tinybird, to actually write an extension pretty much live. So I can just share the link over here so that folks can sign up for this, and you can get to know on how you can start developing upon local stack itself. So yep, these were pretty much all of the updates in and around local stack. Waldemar, if you're there, maybe you can also share a few words from your side before we bring this session to an end.
Yeah, it's been great. So thanks again, Oleg, for sharing the updates on the integration between local stack and test containers. I think it was great to see how easy it is to really run the container from within Java, within your Java application, and then really exposing the different configurations, really making it a seamless transition from your local dev, and then also running the same tests against production, which is really cool. Also, thanks, Harsh, for sharing the updates. Again, we really encourage you to take a look at the version 1.1 features that we recently put out, including cloud pods, bunch of new innovations and new services that got into the new version. So really looking forward to getting your feedback. And also, if you have any topics for upcoming community events, let us know. We're always happy to host any of your contributions in these series. So yeah, thanks again for hosting this, Harsh and Oleg. It's been great.
It was great. Thank you for having me. There is I didn't realize that 1.1 comes with such exciting new features. I thought it was a minor upgrade, but it looks very exciting. So congrats on that.
Definitely. Thanks, Oleg, and I was really happy to have you for this meetup. So thanks for all the great insights that you shared. And even though I'm not a Java developer myself, I'll try to get up and running with the local stack Python, the test containers Python itself, and to see how it works overall. So yeah. Awesome. So thanks everyone for joining. The recording for this meetup will be available upon our YouTube channel. So I have put forward the link upon the chat. So do subscribe it, and it would be just put forward on the channel maybe within 2 or 3 days of this meetup. So yeah. And if you have any questions or queries, just feel free to reach us out on the Slack workspace. Or if you want to speak in an upcoming meetup, just send us a mail to info@localstack.cloud, and we can take that up on priority. So awesome. Have a great rest of the day, everyone, and see you all soon. Bye.
Cheers.